Hello everyone, this is the homework video for Im1, homework number 26, Symmetry and Perpendicular Lines. It's asking you to write the coordinates of points on the graph line, then use those points to determine the equation of the line. So let's start by writing the coordinates. Well, what about this point? The x-coordinate is always the first coordinate, then followed by the y-coordinate. Remember, coordinates are always the x value followed by the y value. X value is 2 right here, so it's going to be 2, and this y value is 3. What about this point here? X value is 5, y value is 3. X value is -1, y value is 3, and x value is -5, and y value is 3. So looking at those coordinates, what do they all have in common? The y value is always 3. Okay, so y value is always 3. So y value is always 3. That's actually my equation. Let's do the next one. Here the coordinate is, the x value is 3, y value is also 3. X value is 1, y value is 1 also. And x value here is -2, y value is also -2. X value is -4, and y value is 4. What is the relationship between x and y? They have the same value, don't they? Whatever x is, it's going to be the y. Whatever x is, it's going to be the y. So the equation is y is equal to x. They have the same value. That's how they are related. This is also same as saying y is equal to 1x plus 0, where 1 is the slope. Slope is rise over run. So rise is 1, run is 1. So 1 and the y-intercept is 0. Okay, so they're the same thing. What about C? See, what are the coordinates here? The x-coordinate is 1, y-coordinate is -1, x-coordinate is 3, and y-coordinate is -3. Excuse me. X value is -1, y-coordinate is +1, and here x value is -2, y value is 2. And what is the relationship between these two? Okay, whatever x is, has the same value. The number is the same, but the opposite in sign. So y is equal to -x. Alright, then last one, D. What are the coordinates? Here, x is 3, y is 4. This one is x is 3, y is -1. X is 3, y is -3. What do they all have in common? What is the pattern here? All the x value is always 3. So that's why the equation is x is equal to 3. Now let's see. In the English alphabet A, B, C, D, E, F, G, all the way to Z, which letters have a reflection symmetry? Draw the letters below and show the lines of symmetry. Okay, so how can I cut this image A such that it's going to match up exactly or fold over exactly? If I fold it right here. What about B? If I folded it right here. What about C? If I folded it right across here. What about D? Right here. E, same thing here. And F, there's no reflection symmetry. What about G? No reflection symmetry. H, there's multiple. You can cut it across here or here. I, you can cut it across. J, there's none. K, depends on how you write it, but I'm going to say no. Well, you can cut it right across. L, there's none. M, you can cut it right here. N does not have a reflection symmetry, but it does have a rotational symmetry. O, you can cut it depending on how O is written many different ways. P, there's no reflection symmetry. Q, none. R, none. S, there's a rotation symmetry but not reflection symmetry. T, there is a reflection symmetry. U, there is a reflection symmetry. V, yes. And W and X would work in many different ways. X would be 1 and Y, you would have that, and Z, there's none. Okay, so summarizing this, A, B, C, D, E, F, none, H, I, J, none, K, L, none, M, N, no, O, P, none, Q, R, S, T, U, V, W, X, Y, and Z, none. And where are the reflection symmetry? A could be cut in half like so, and B, depending on how you write it, if it was written this way, okay, where this is a symmetrical image, then you could have it cut right there or reflected right here, and C likewise here. D and E and H could be reflected along horizontal and vertical line. I could be horizontal, K could be horizontal, M could be vertical, and O could be many different directions. Okay, and T is vertical, and U is vertical, V is vertical, W is vertical, X is many different ways depending on how it is written, and then Y will be vertical. Alright, now let's go to the other side. For each of the figures below, decide if it has a reflection symmetry, rotation symmetry, neither. If reflection symmetry, decide on how many lines of symmetry it can have. If rotation symmetry, decide on what is the order of the rotational symmetry. Okay, so in this case, reflection symmetry, can I reflect it in such a way it would match up exactly, fold over exactly? Yes, I can reflect it this way, up, and along here. There is 1, 2, 3 lines. Is that it? No, I can also fold it over about here. 5, 3, 4, 5, and 6. So reflection symmetry, yes. How many? 6. Okay, rotation, order rotation symmetry. Okay, rotation symmetry. If I was to trace this, and this is the top, how many times can I rotate it such that it will match up? It will be 6 times also. Yes. Alright, what about this? Reflection symmetry. How can I fold it or cut it in half so that its left and right is exact match? Just one way. So there is only one reflection symmetry, but it does have it. What about rotational symmetry? Can I turn it in such a way that it will match up? Not until we get 360 degrees, and if that is so, then we do not say it has a rotational symmetry, so it's no, and so there's no order of rotation. Reflection symmetry. Can I cut it in such a way that left and right will be exactly the same? I don't think so. Okay, if it was just a circle, yes, but we have all these lines. If I cut it here, it's not going to match up. If I cut it here, or any direction, it's not going to match up. So no reflection symmetry. But can I turn it in such a way it matches up? Yes, if I turn it 120 degrees or 1/3 of a rotation, it will match up because there's a repetition here, here, and here. So there is a rotational symmetry, yes, and order of rotation within one full turn there are 3. What about this? Reflection symmetry, can I cut it in such a way that I can match up? If I cut it along here, it would not match up exactly. Okay, so if I reflect it, put a mirror in the middle, that it would not reflect to match up. So the answer for this is no. How many lines of symmetry? There's none there. Rotation symmetry, can I turn it in such a way that it will match up? Yes. Okay, so if I was to show you, let me draw it and demonstrate that. This is my top here. Okay, so if I turn, when can I match up? Bam. Oh, it almost did, but not quite. Ah, it looked like it did, but when I actually use the tracing paper, it does not. Okay, it does not. So I am going to say no. Okay, it almost looked like it did. Alright, so what is the equation of the line that's perpendicular to y is equal to negative 4 over 7x plus 4 and has the y-intercept of 0, 5. Okay, so then the original slope is, what is the original slope? It is negative 4 over 7. That's the number in front of x. Okay, so that means the new perpendicular slope is going to be, you flip the fraction. Okay, so instead of 4 over 7, it's going to be 7 over 4. And if it was negative, it becomes positive, or if it was positive, it becomes negative. Okay, so new perpendicular slope is going to be positive 7 over 4. What do we know about, and so that means that's the m value. What do we know about the y-intercept? Y-intercept is 0, 5. That means the b value, it's going to cross the y-axis at when y is equal to 5, or the b value in this case is 5. Putting it together, the new equation is going to be y is going to be equal to positive 7 over 4x plus 5. Okay, last problem. That are perpendicular to y is equal to 2x and has y-intercept of 0, negative 3. 0, negative 3 means that b value is negative 3. The original slope is 2. And 2 is same as saying 2 over 1. Okay, so then perpendicular slope is going to be, flip the fraction, 1 is at the top, 2 is at the bottom. It was positive, now it's going to be negative. Okay, so then putting it together. So this is my m value, and I have my b value. So I have the equation as y is equal to negative half. Don't forget the x. That's the number in front of the x. That's the slope. Plus negative 3. So that's my equation. Alright, thank you for listening.